I couldn't hear you.
The handle of that factory.
Yes.
I can't find my.
You were here last time?
I was, but for some reason.
Yeah, I don't think I have another one, just this. So I'll give it to you when we finish because I may have to go back to it. If I have another, I'll give this one to you at the end of the class. But I may need it for a second to pick a problem or two. So you'll have it at the end. I'm sure you'll find it at home, but I don't mind giving it to you. I have others, but they're downstairs. Okay, I would like to start with on page 645. There is a chapter test review, and there is a chapter 10 test. So I would like to go over those problems, and then we'll go back to chapter 9 and review 9, 2, 3, and 4. And then we'll come back if we have time and do more problems from chapter 10. And it is your responsibility to redo all problems we did in class from the lecture notes and the videos between now and when you take the test. And I highly recommend do your homework to the best of your ability, and you can come back and increase your grade or something, but I would like you to work on the homework problems. That's how you realize whether, oops, I know it or I don't. Okay? So let's start with page 645. We are reviewing 10.1. My question is, would you like to go backwards, or you would like to start with 10.1, or you want to go backwards from 10.7 back?
Let's go backwards.
The reason why I prefer going backwards is I'll tell you why. Because those initial problems are just very simple and basic little problems like those you will not see on the test. So they will be a little bit more involving, testing your understanding of this chapter. So I'd rather go backwards. Okay, so let's start with 10.7. Okay, page 647. 10.7, page 647. Please feel free to choose, okay? I'm looking at 10.7 problems 127 through 159. But that is a mixed review. So maybe we should start with a mixed review. Okay, mixed review, page 647. Problems 141 through 159. This is a very good practice now. I'll choose one, you choose one, okay? Because I would like to cover everything, and if we have time, we'll come back and do more. Okay, I would like to choose 145. So I have a fourth root of y to the 20th over 16 x to the 12th. I like this problem because I am going to use the rule that allows us to write the fourth root of y to the 20th, the fourth root of 16, and the fourth root of x to the 12th. I'm allowed to do that because under the fourth root I have product and ratio. I would not be able to write this if I had the fourth root of a plus b. I could not write the fourth root of a plus the fourth root of b. Now I'm using what I learned on the first page and on the handout, that the fourth root of y to the 20th can be replaced by very good. 20 divided by 4, y to the 5th. Then I know that the fourth root of 16 by now, I know that that is very good. And then the square root of x to the 6th is I think I'm sorry. Okay, the square root of x to the 12 is x to the 6. I'm sorry. Okay, I lost my mind for a second. Okay, now please choose the next one, please. We're still working on 143 through 159. Yes. So let's look at 159. In 159, we are asked to solve the equation. And the equation is the square root of 2x minus 1 plus 2 equals x. So I'm asked to solve this. So what is it, first of all? It's an equation. What type? It could be linear, quadratic. It could be absolute value. It could be... So what is it? Look at what it has and you will know what it is.
Rational.
If it had a ratio, it would have been irrational. It cannot be quadratic. It doesn't have x squared. So what is it? What is this whole chapter all about? What did we study in this chapter? What is the title of the chapter? Say it again. It has a radical. If it has a radical, it must be a radical equation, right? Okay, very good. So this is a radical equation. It has a radical, right? If it has a ratio and x in the denominator will be rational. If it has x to the first power, it's linear. If it has x to the second power, it's quadratic. If it has the absolute value in it, it's the absolute value equation, correct? Okay, how do I solve this? What would be the first step? I need to... My first step is to isolate the radical. I need the radical to be alone on one side. What do I have on the right-hand side? Perfect, excellent. That's my first step. If the radical equation has only one radical, I must isolate it. Okay, I did. Next, what should I do? My hope is that I can get rid of the radical. How could I get rid of the radical? What should I do to both sides in order to get rid of the radical? Indeed, I have to square both sides, of course. That's the only way to get rid of the radical. What if the index were 3? Would I have squared both sides? Cube both sides. Excellent. Very good. So then what would be my next step? What do I get on the left? Right, indeed, that's what I want, 2x minus 1. Because the power on 2x minus 1 is what? The square root means what power? No, it has to be a fraction. The square root means power that is a fraction. We know that. A radical is an exponent with a fractional, exponential notation with a fractional exponent. So the square root means what power? That's why we squared. So what will be this power? It cannot be 2. It has to be a fraction.
1.
It cannot be 1. 1/2. That's why we square both sides. To eliminate power 1/2. 2 times 1/2 and 1/2 will be 1. Good. What about the right-hand side?
X squared minus 4x plus 4.
Excellent. Thank you. You saved me. Because if I had heard x squared minus 4, my head would have said, "Woo!" Thank you. Thank you, Heather. Good. Now what equation is this? We learned linear, we learned quadratic, we learned absolute value, we learned radical equations. What is it? If I have difficulties in identifying it, I may have bigger difficulties in solving it. This is quadratic. Quadratic equation indeed. So now how do I solve a quadratic? I ask myself, what do I do next? What do we do with quadratic equations? Excellent. So I have to move 2x and I have to move 1. So x squared, I subtract 2x and I add 1. Put it on any side you want. You don't have to trust me. Do it your way and see what you get. So I subtracted 2x from both sides, and I added 1 to both sides. Now, because the leading coefficient is 1, I should not have difficulties in factoring this. How do I factor this? And this on the handout that I gave you last time is right here, is this item on page 3. Completely factor the trinomial of type 1 times x squared plus bx plus c. In the middle of page 3. 1 x squared plus bx plus c. And of course, there is a theory behind it, and I have examples. So here's the theory behind factoring this. When the leading coefficient is 1, okay? I'm looking for two numbers whose product is always the last, assuming this is in descending order. If it's not in descending order, I will not know how to identify what, right? So the product is always this. This is always the product when the leading coefficient is 1. And the sum is always this, sum, the middle coefficient. So now I'm asking you, can I find two numbers whose product is 5 and whose sum is -6? So here's how I think. First of all, the product is positive. Therefore, both numbers have to have the same sign. Because if one is negative and one is positive, the product will be negative. So they are both positive or both negative. But their sum is negative. So now I know exactly what sign they have to have. Which sign? Correct. So can we find two numbers, two negative numbers, whose product is 5 and whose sum is -6? Say it again. If I do that, first of all, the sum is not -6, and the product is not +5. Both conditions have to be fulfilled. So I need two numbers whose product is 5, two negative numbers.
-1 and -5.
Perfect. So -1 and -5. These are the numbers I need to factor with. So x minus 1 and x minus 5.
When you do that, does it matter at all which number it is?
No, because 2 times 3 is 3 times 2. So if I write x minus 1 times x minus 5 and you write it x minus 5 times x minus 1, it doesn't mean that you found a different factored form. It's still the same. And still the same result. So x equals what and x equals what? Remember the zero product principle. If two factors, the product of two factors is 0, either one can be 0. If x minus 1 is 0, what do we get? Exactly. Because 1 minus 1 will be 0. If x minus 5 is 0, then x is 5. However, remember, we used the principle to solve, a principle that cannot always be trusted. So we squared both sides. I have to go back and do what? Yes, I'm checking 1. What type of number is the square root? The final outcome of a square root. The square root of anything. What is the answer? Always. Or 0. Excellent. So positive or 0 plus 2, can it be 1? No. Let's check though. We know it's not going to work. 2 times 1 is 2. 2 minus 1 is 1. The square root of 1 is 1. 1 plus 2 is 3. So what will you say about x equals 1? Extraneous solution, unacceptable. Now we have to go back and repeat the same procedure, okay, checking with 5. Let's check with 5. This has potential. 2 times 5 is 10. 10 minus 1 is? Square root of 9. 3 plus 2. Will you accept x equals 5? You have to, because it's the only solution and it works. Perfect. Anything else from 141 through 159?
Can we go over number 151?
Yes, 151. So in 151, we have the square root of 3n cubed divided by 121 m to the 10th. Perfect. Again, I'm allowed to separate it. But I will separate it in such a way that I can simplify it. So I don't have to write it again. So I see inside there is nothing I can do. 121 is not divisible by 3. There is nothing I can simplify. So this is my only bet. Can anyone explain why I broke n to the third into n squared and n? Why did I break it up like that? Exactly. The square of n squared will be n because it's 2 over 2. Excellent. So now the denominator is the square root of 121 and the square of m to the 10th. How come that I did not do anything with to m to the 10th? Why didn't I break that up into 9 and 3? There is no need. Why? Why there is no need? Exactly, it's an integer. It has an integer as the power. Excellent. Good. So then this will be replaced again by, assuming everything is positive, this will be replaced by, very good. This will be replaced by, perfect. And this will be replaced by m to the, that's it. So then I have n, the square of 3n over 11m to the 5th. And there is nothing else. I think we should look at 149. I think we should look at 152 and 153, and also the distance and the midpoint. And rationalizing. This is a very good summary. And also 142. Any questions so far? Okay. Okay, so let's start with, I'm going back to 141. The cube root of x to the third. It says, use absolute value bars when necessary, meaning x can be any real number. So what will be the answer on this? Yes. How come that it didn't say the absolute value of x?
Because the right
Index
is
an odd,
number.
exactly. Good, perfect. 142. The square root of x plus 2 squared. What is the answer? Any suggestions?
Absolute value of x.
Very good. So it's 2 over 2. The power will become 1. And power 1 could be negative if x is negative. See, if I don't put the absolute value and x is negative 3 plus 2 is negative. And this quantity cannot never be negative. The square root, we graphed it. This is the x-axis, the graph of the square root of this. So it's always above the x-axis. So the answer of the square root, unless it has minus in front, but that's not the case here, will always be positive. Very good. Let's look at 152. No, I'm sorry, I said 149. X to 2/3 times x to -3, everything to the third, over x to -1/2. Okay, first step. Any suggestions here, please? What do I do here inside? I have here two options. One option is to perform the operation inside, copy the base, and what will I do with the exponents? Add, subtract, multiply, or divide. Which one? Of course, of course. However, I noticed something, that if I raise this to the third power, the fraction goes away. If I raise this to the third power, it's going to be okay, still an integer. So let's do that first, instead of adding those. So when I raise x to 2/3 to the third, I copy the base. One more time, what happens to 2/3 and 3? What do I do with these two? Multiply. So on the side, look at this, 2/3 times 3/1. Always simplify first, and then you get 2. So this is x squared. Now I multiply by x, I copy the base, and again, what do I do with the exponents? Exactly what I did before. Right, so then I get -9. And then I copy the denominator. This is what I would have done. And now I know what I have in the numerator. I copy the base, and what happens to the exponents? Good. So 2 minus 9 is -7. And finally, I copy the base, because I'm dividing now two exponential notations. I copy the base. And what do I do with the exponents next? No, there is no need to do that. I'm not saying it's wrong. There is no need to do that. I'm dividing. I copy the base. What happens to the exponents? Add, subtract, multiply, divide. Of course, -7 plus 1/2, because I subtract a negative number. When I subtract a negative number, that changes into positive. So now, what do I need in order to add, or if you want to subtract, whatever you want to say, those two? I need to find. Very good. So what is the least common denominator of these two? 2. What is the adjustment for -7? It has denominator of 1, and I change it to 2. So it needs a 2. So -14 plus 1. So that is -13/2. Are you with me so far? Okay. So x to -13/2. I know along, where is my handout? Oh, I just found another one. Here it is. Okay, so if you remember, on page 5 of the handout at the top, radical expressions are fully simplified if there are no negative exponents in the final answer. The exponents under the radicals are numbers smaller than the index of the radical. There are no radicals in the denominators. Always keep that in mind. So the problem is not finished. It has a negative exponent. So what do I do next? What do I do with a negative exponent? You have the exponential rules, all of them on page 3. Here they are. We wrote all of them on page 3. Without remembering these and practicing these, you're going to come to a stall. So what is it? A base raised to a negative exponent. What do I replace it by? Yes. 1 divided by x to positive 13 halves. Good. So the power changes. Good. What now? What will be my next step? Exactly. Thank you. I have to turn it into a radical. Very good. What radical is that? What index?
2,
Good. X to the?
13.
Perfect. I will break up x to the 13th into what? I need 2 powers. Remember how you do it. 13 divided by 2. No. 12 divided by 2. Yes. So what do I need to break it up into? 12 and 1 indeed. So this will be the square of x to the 12th times the square of x. How much is the square of x to the 12th? We just had it a second ago and I messed it up. 1 over x to the 6th times the square of x. Perfect. Which portion of the entire denominator needs to be rationalized? Because x to the 6th does not. It's not irrational. It doesn't have a ratio. It doesn't have a radical on top of it. So there is one piece that needs to be rationalized. Which one? Right. So how do I rationalize the square of x? I have to multiply and divide by what? It has to be the same index. The index is 2. So how many x's do I have? 1. How many do I need?
2.
2 will make it 3. And I don't need 3. I don't need to have a total of 3. The index is 2. I need a total of 2. I have 1. I'm missing 1. So x and x. So disregard all this. I'm going to continue on the next page. So then what? The numerator is the square of x. How much is this when I multiply them? X times x to the 6th. What do I get in the denominator? That's it. A lot of work. A lot of work. First, I had to get rid of the parentheses. Then I had to divide. Then I used the least common denominator to find this. Then I changed it into this. Then I changed it into a radical. Then I had to split the radical because 13 divided by 2 is not an integer. I split the radical. Then I'm here. Then I have a radical in the denominator. Then I rationalize, and then I get the final answer. A lot of work. I mean, I shouldn't say a lot of work, but a lot of steps. Let's look at 152. Any questions for me? Any questions? Any questions, please? Okay, 152 then. 3. The square of 20 minus 7x. The cube root of 40 plus 3. The cube root of 5x cubed. So we're asked to, as you see, add, subtract these radicals. Well, they don't appear to be like radicals. So I have to try and simplify fully each and every one of them and then figure out whether I can add them or not. I know for sure that one of them will not belong with the other two. Which one will definitely not be combined with the other two for sure? Which one?
Last one.
No. The first one does not have x in it. So these may be eventually like radicals, but they will never be the same with this. I cannot make up an x. So this is definitely totally different than the other two. Perfect. So how will I break 20? Because the square root of 20 is not an integer. So I have to break it up into Indeed. How will I break up 40? Now this time, and the other thing is that this has the square root. It doesn't have, and it doesn't even have the cube root. Okay, so now I have to find a cube and perfect cube in 40, and then I have to look at x cubed. Oh, actually, x cubed doesn't. I'm still thinking of the square root. X cubed does not need anything. Good. So can anyone simplify or tell us a perfect cube in 40? Eight and 5. Very good. I put that 5 too close to 4, and I didn't want to confuse you. Good. Very good. So then I will write first step, 3 the square root of 4 the square root of 5 minus 7x the cube root of 8 the cube root of 5 plus 3 the cube root of 5 and the cube root of x cubed. I'm okay if you skip this step, but I think it's wise not to at the beginning anyway, when you study for this test. Good. So how much is this? How much is this? And how much is this? This is 2. But I have to multiply it by 3 in front. So what do I have to write? Yes, 6 the square root of 5 minus. How much is the cube root of 8? Good. So I have to multiply by 7 though. So it's negative 14x the cube root of 5. How much is the cube root of x cubed? Good. I have to put it in front next to 3. So plus 3x the cube root of 5. So now these all radicals are completely, fully simplified. So now the question is, any of those are like radicals? If they are, then I will combine them. If they're not, then I will leave it alone. We know that 6 the square root of 5 has to stay. Are the other two like radicals? Do they have the same irrational part, the same index, the same radicand, the same variables in front at the same powers?
Yes.
And then in that case, I can say negative 14 plus 3, which is? And this is fully simplified. Okay. 2 the square root of x, so this is 153. 2 the square root of x minus 5, everything squared. 1 or 2 or 3 or 4 problems of the same kind may not guarantee you establishing a skill and being able to reproduce it on the test on your own. So please keep that in mind. Okay? Good. So I'm asked to square 2 the square root of x minus 5. If this, we look at this expression as a binomial. When I square a binomial, how many terms do I get? That's what I don't want to hear, because we have an agreement that we signed on the first day of classes. 3 terms. Very good. So the first term squared. So I have to square 2 the square root of x, which means I have to square 2, which gives us 4. And I have to square the square root of x, which gives us, very good. Now the next term, remember, is minus, because I have minus in the middle here. And careful how we multiply. 2 from the formula times 2, which is 4, times 2 times 2 is 4, times 5, times the square root of x. So 20 the square root of x, and plus The second term squared. Indeed. And this is it. Let's find the distance and find the midpoint. And then rationalize. And then go back to other problems. In preparation for this test, after you study hopefully all sections or even piece by piece, I will come back to the review test for chapter 10. Okay? It's separated by section. And I will do all those problems because all of them have the answers in the back. Okay, distance. We are given 2 points. This is problem 154. We're given 2 points, -3, 5, and -8, 9. We're asked to find the distance between these two. What is the distance formula? The distance formula is
D
square root x2 minus x1, everything squared, plus y2 minus y1, everything squared. Now careful. This will always be what type of number? No matter what you do here, this will always be what type of number? Right, because it's squared. There is no discussion there. What type of number will this be? Right, and when you add two positive numbers, will I ever see d equals the square root of -39? No, I can never see that, right? Okay, perfect. So now all I do is write those coordinates underneath, right? So this is x1, y1, this is x2, y2. So I write -8 minus 3, and I write 9 and 5. Then I step back and look. I don't want to make a mistake. So then d equals the square root. Let's do it together, please. -8 minus -3. -8 minus -3 will be -5 squared, because I'm not allowed to write a negative number here. -5 squared is 25 plus. Very good. 9 minus 5. 4 squared. Good. So d equals, remember you cannot take the square root, you cannot separate this, you cannot do anything here. You cannot touch this. The square root of 41. And that's it. The midpoint. So let's determine the midpoint for the same problem. So the midpoint is asking us to add the two x values. Please add them. -3 minus 8. You give me $3 and then tomorrow I say, please give me 8 more. How much do I owe you? 11. So this must be over 2. -11 over 2, comma. Let's add the y values. It's the average of x's and comma the average of y's. Let's add 5 plus 9 to 9. How much? Divide that by 2. 7. That's it. That's the midpoint. It's the point that will divide the segment into two equal parts. Very good. Let's look at a rationalizing. Problem 157. 2 divided by the square root of x plus 3. We're asked to rationalize the denominator. What will I rationalize the denominator by? What do I have to do?
Multiply by the common to give the Good enough.
Excellent. And this is the conjugate of the denominator. Please use the special product we reviewed on the first day of class, our contract. The square root of x plus 3 times the square root of x minus 3, so you don't make a mistake. That is the difference of squares. Please square the first term. Perfect. Minus is the difference of squares. Minus, please square the second term. Good. Now the numerator you can distribute or not. I'm fine if you leave it as is, because no one can simplify this. I'd like to look at the chapter test, like problem 7. 7 on 647. 64. It's not C raised to 4/3. Everything, the whole thing is raised, sorry. A to negative 2/3 and B to 5/6. Everything is raised to 1/2. These are all radicals, but I'm not going to change them into radicals till the very end. Good. So if you ask me to simplify this expression, let's read the requirement. Raise to the power or find the root. Assume that all variables represent positive numbers. If I'm told that all variables represent positive numbers, what can I forget about?
Absolute value.
Thank you very much. I can forget about the absolute value. Write with only positive exponents. Good. So if you give me this problem, first of all, I will look inside. I will look inside here and ask myself, is there anything I can simplify? No, there isn't. 64C, A, and B have no common factors. There's nothing I can do. Then my next question to myself is, okay, maybe I can remove this. And the answer is yes, I can. So I will raise this to this power. 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 So when I raise 64 to 1/2, what does that mean? 64 raised to 1/2. Let's change it into something that I can simplify. What does 64 raised to 1/2 mean?
Square root of 64.
Exactly, which is? That's it. Now I have to copy the base, which is C. And what procedure, what operation I perform with 4/3 and 1/2? Add, subtract, multiply, or divide?
Multiply.
Multiply. 4/3 times 1/2, you should simplify and get 2/3. Correct. Then I copy the base, which is A. And what happens to negative 2/3 and 1/2? Add, subtract, multiply, divide. Which one? Right. So I have 2/3 times 1/2, and that is negative 1/3. And finally, I copy B. And I have 5/6 and 1/2. 5/6 times 1/2 is 5/12. Any questions so far? This isn't done. And I guarantee you I will not put a problem like this on the test. But since we started out, I'm going to finish it. Okay, 8 is fine. C is fine. B to the 5/12 is fine. But this has to go to the numerator. So it's 8A to 1/3 positive, C to 2/3, and B to 5/12. You can rewrite the numerator. How? Look at A to 1/3 and C to 2/3 and tell me how to rewrite it. If you think in terms of radicals, what will be the index for both? Right, and that's what I'm going to do. The cube root of AC squared. Very good. And now the denominator. How do I rewrite the denominator using a radical? The
Index is 12.
very good. And b to the fifth. The last thing that I would need to do is to rationalize the denominator. And we cannot multiply the cube root by the 12th root. We have to perform another procedure in there, but I'm not interested in that. You're not going to see it again, so I'm not going to force that. But I would like to rationalize the denominator, though. What index will rationalize the denominator? Index 3? Index 5? 7? No. Only one. Which one? Of course. Only the 12th root will rationalize the denominator. How many total b's I should have to eliminate the radical? I should have a total of 12, but I only have 5. Since I only have 5, I am missing how many of them I'm missing? Yes, b to the 7th and b to the 7th. Do not multiply the two numerators. You cannot because they have different indices. 8, the cube root of AC squared, multiplied by the 12th root of b to the 7th, divided by. All I care about is what is in the denominator. What is it? Exactly, because it's the 12th root of b to the 12th, and that's exactly what we wanted to do, to rationalize the denominator. Excellent. Very good. Okay. Let's rationalize 13. The cube root of AB over the cube root of AB squared. We're asked to rationalize the denominator. I refuse to rationalize the denominator before I fully simplify this radical if I can. And the answer yes is yes, I can. How do I know? First of all, they have the same index, top and bottom, and I see A and I see B in both. So I'm going to rewrite everything with one index, simplify inside the radical, and then separate it again and decide what to rationalize. So I see that A is gone. I don't want to waste my time and rationalize that if it's gone already. And I see B will be gone. 1. So what I have is the cube root of 1 over B, which is the cube root of 1 over the cube root of B. I'm allowed to do that. And this is 1 over the cube root of B. And I know exactly what will rationalize this denominator. What will rationalize this denominator? Index 5? No. I'm trying to be funny. Index 3? Yes. It has to be the same index. Otherwise, I won't be able to multiply them and I'm not getting what I need. How many total b's should I have? 3. How many do I have? I have only 1. How many I need? 2 of those. So the numerator is clear. What about the denominator? The denominator should be clear as well. What is it? Exactly. It's our target. That's what we wanted. We wanted to rationalize the denominator. I would like us to think about this problem. Assuming that x can be any real number. X can be any real number. I would like to simplify this. How do we do that?